Chapter 7, Planning and Control. The design of an operation determines the resources which it creates its services and products. But then, the operation has to deliver those services and products on an ongoing basis, and central to an operation's ability to deliver is the way it plans its activities and control them so that customers' demands are satisfied. This chapter introduces and provides an overview of some of the principles and methods of planning and control. Learning objectives. After completing this chapter, you should be able to explain planning and control, discuss the difference between planning and control, elaborate how supply and demand affect planning and control, enumerate the activities of planning and control. Learning contents. Topic 1. What is planning and control, or difference between planning and control? Topic 2. Supply and demand affect planning and control. Topic 3. Activities of planning and control.
Planning and control. Planning and control are concerned with the activities that attempt to reconcile the demands of the market and the ability of the operations resources to deliver. It provides the systems, procedures, and decisions which bring different aspects of supply and demand together. Consider, for example, the way in which routine surgery is organized in a hospital. When a patient arrives and it is admitted to the hospital, much of the planning for the surgery will already have happened. The operating theater will have been reserved, and the doctors and nurses who staff the operating theater will have been provided with all the information regarding the patient condition. Appropriate pre-operative and post-operative care will have been organized. All this will involve staff and facilities in different parts of the hospital, all of whom must have been given the same information and their activities coordinated. Soon after the patient arrives, he or she will be checked to make sure that the condition is as expected, in much the same way as material is inspected or arrival in a factory. Blood, if required, will be cross-matched and reserved, and any medication will be made ready, in the same way that all the different materials are brought together in a factory. Any last-minute changes may require some degree of replanning. For example, if the patient shows unexpected symptoms, observation may be necessary before the surgery can take place. Not only will this affect the patient's own treatment, but other patients' treatment may also have to be rescheduled, in the same way as machines will need rescheduling in a job is delayed in a factory. All these activities of scheduling, coordination, and organization are concerned with the planning and control of the hospital. What is the difference between planning and control? Notice that we have chosen to treat planning and control together. This is because the division between planning and control is not clear, either in theory or in practice. However, there are some general features that help to distinguish between the two. Planning is a formulation of what is intended to happen at the same time in the future. But a plan does not guarantee that an event will actually happen. Rather, it is a statement of intention. Although plans are based on expectations, during their implementation, things do not always happen as expected. Customers change their minds about what they want and what they want it. Suppliers may not always deliver on time, process technology may fail, or staff may be absent through illness. Control is the process of coping with these types of change. It may mean that plan needs to be redrawn in the short terms. It may also mean that an intervention will need to be made in the operation to bring it back on track. For example, finding a new supplier who can deliver quickly, getting process technology up and running again, or moving staff from another part of the operation to cover for absentees. Control activities make the adjustment which allow the operation to achieve the objectives that the plan has set, even when the assumptions on which the plan was based do not hold true.
Topic 2. How do supply and demand affect planning and control? If planning and control is the process of reconciling demand with supply, then the nature of decision taken to plan and control an operation will depend on both the nature of demand and the nature of supply. In that operation, in these sections, we examine some differences in demand and supply which can affect the way in which operation managers plan and control their activities. Uncertainty in supply and demand. Uncertainty is important in planning and control because it makes it more difficult. Sometimes the supply of inputs to an operations may be uncertain. Local village carnivals, for example, rarely work to plan. Events take longer than expected. Some of the acts scheduled in the program may be delayed en route, and some traders may not even arrive. In order operations, supply is relatively predictable and the need for control is minimal. For example, cable TV services provide programs to schedule into subscribers' homes. It is rare to change the program plan. Similarly, demand may be unpredictable. Dependent and independent demand. Some operations can predict demand with relative certainty because demand for their services or products is dependent upon some other factor which is known. This is known as dependent demand. For example, the demand for tires in an automobile factory is not a totally random variable. The process of demand forecasting is relatively straightforward. It will consist of examining the manufacturing schedule in the car plant and deriving the demand for tires from this. If 600 cars are to be manufactured on a particular day, then it is simple to calculate that 3,000 tires will be demanded by the car plant. Demand is dependent on a known factor, the number of cars to be manufactured. Because of this, the tires can be ordered from the tire manufacturer to a delivery schedule which is closely related to the demand for tires from the plant. In fact, the demand for every part of the car plant will be derived from the assembly schedule for the finished cars. Other operations will act in a dependent demand manner because of the nature of the service or product which they provide. For example, a custom-made dresser will not buy fabric and make dresses in many different sizes just in case someone come along and wants to buy one, nor will a high-class restaurant begin to cook food just in case a customers arrive and request it. In both these cases, a combination of risks and the perishability of the product or service prevent the operations from starting to create the goods or services until it has a firm order. Planning and control is dependent demand situations is largely concerned with how the operation should respond with demand has occurred. Responding to demand. It is clear that the nature of planning and control in any operations will depend on how it responds to demand, which in return related to the type of services or product it produces. For example, an advertising agency will only start the process of planning and controlling the creations of an advertising campaign when the customer or client as the agency will refer to them. Confirm the contract with the agency. The creative design of the advertisement will be based on a brief from the client. Only after the design is approved will the appropriate resources directors, scriptwriters, actors, productions company, etc. be contracted. The actual shooting of the advertisement and post-productions, editing, putting in the special effect, etc. then goes ahead, after which the finished advertisement and delivered through television slots.
Topic 3. What are the activities of planning and control? Planning and control requires the reconciliation of supply and demand in terms of volumes, timings, and quality. In these chapters, we will focus on overview of this activity that plan and control volume and timing. Most of this part of the book is concerned with issues. There are 4 overlapping activities: plaging, sequencing, scheduling, and monitoring and control. Some caution is needed when using this area terms. Different organizations may use them different ways, and even textbooks in the area adopt different definition. For example, some authorities term what we have and planning and control as operation scheduling. However, the terminology of planning and control is less important than understanding the basic areas described in the remainder of this chapter. Number 1, loading. Loading is the amount of work of the allocated to work center. For example, a machine of the shop or floor of a manufacturing business is available in theory of 168 hours a week. However, this does not necessarily mean that 168 hours of can be loaded on the machine. For some periods of machine cannot be worked. For example, it may not available on the statutory holidays and weekends. Therefore, the load put on the machine must be take this into account. Of this time that the machine is available for work, other losses further reduce the available time. For example, that may be lost while changing over from making one of component of another. If the machine breaks down, it will not be available. Number 2, sequencing. Sequencing. Whether the process of loading is finite or infinite. When work arrives, decision must be taken on the order in which the work will be tackled. This activity is termed sequencing. The priorities given to work or operation are often determined by some predefined set of rules. Some of are the relative complex, some of these summarized below. A. Physical constraints. The physical nature of the inputs being processed by determining the priority of work. For example, if an operation using paints or dyes lighter shades with a sequences before the darker shades. On completion of each batch, the color is slightly dark for the first batch. This is because darkness of color can only added to and not removed from the color mix. Sometimes the mix is work arriving at part of other operation may be determine the priority given the jobs. For example, when fabric is cut a required size and shaped in the garment manufactures, the surplus fabric would be waste on not used for another product. Therefore, jobs that physically fit together may be scheduling together to reduce waste. And B. Customer priority. Operation will be sometimes use customer priority sequencing, which allows important or aggrieved customer or item to be processed prior to others irrespective or others to arrivals of the customer of item. This approach is typically used by operation whose customer base is kept containing or mass of small customer and few large very important customer. C. Due date. Prioritizing by the date means the work is sequenced according to when it is due for delivery, irrespective of the size of each job and importance of its customers. For example, a support services such as printing a unit. It will often ask when copies are required. Then, the sequence work according to that due dates. Due dates are sequencing usually improve the delivery dependability and average delivery speed. However, it may not providing optimal productivity, as a more efficient sequencing of work may reduce total cost. However, it can be flexible when new urgent works arrive of the workplace. And the last is first out LIFO. Last in first out LIFO is method sequences usually selected for particular reason. For example, unloaded an elevator is more convenient on a LIFO basis as there is only one entrance and exits. However, it is not an equitable approach. Patients at hospital clinics may be infuriated is the newly arrived patients examined first.
Letter E. First in, first out. Some operations serve customers in exactly the sequence they arrive in. This is called first in, first out sequencing, or sometimes first come, first serve. For example, UK passport office received mail and sort in according to the day when it arrived. They work through the mail, opening it in sequence, and process the passport application in order of arrival. Queues in theme park may be designed so that one long queue sneaks around the lobby area until the row of counters is reached. When customers reach the front of queue, they are served at the next free counter. Letter F. Longest operation time. Operations may feel obliged to sequence their longest job first, called longest operation time sequencing. This has the advantage of occupying work sentries for long periods. By contrast, relatively small job progressing through an operation will take up time at each work sentry because of the need to change over from one job to the next. However, although longest operation time sequencing keeps utilization high, this rule does not take into account delivery speed, reliability, or flexibility. Indeed, it works directly against these performance objectives. Letter G. Shortest operation time. Most operations at some stage become cash constrained. In these situations, the sequencing rules may be adjusted to tackle short job first. This is called shortest operation time sequencing. These jobs can then be invoiced and payment received to each cash flow problems. Larger jobs that take more time will not enable the business to invoice as quickly. This has an effect of improving delivery performance if the unit of measurement of delivery is jobs. However, it may adversely affect total productivity and can damage service to larger customers. Letter H. Judging sequencing rules. All 5 performance objectives, or some variants of them, could be used to judge the effectiveness of sequencing rules. However, the objectives of dependability, speed, and cost are particularly important. Scheduling. Having determined the sequence that work to be tackled in some operations required a detailed timetable showing at what time or date jobs should start at when they should end. This is scheduling. Schedules are familiar statements of volume and timing in many consumers' environments. For example, a bus schedule shows the more buses are put on routes and at more frequent intervals during rush hours periods. The bus schedules show the time each bus is due to arrive at each stage of the route. Schedules of works are used in operations where some planning is required to ensure the customer demand is met. Other operations, such as paid response service operations, where customers arrive in an unplanned week, cannot schedule the operation in short-term sense. They can only respond at the time demand is placed upon them. Monitoring and controlling. The operation having created a plan for the operation through loading, sequencing and scheduling each part of the operation has to be monitored to ensure that planned activities are indeed happening. Any deviation from the plans can then be rectified through some kinds of intervention in the operation, which itself will probably involve some replanning. The output from a work sentry is monitored and compared with the plan, which indicates what the work sentry is supposed to be doing. Deviation from this plan are taken into account through replanning activity and necessary intervention made to the work sentry, which will hopefully ensure that the new plan is carried out. Eventually, however, some further deviation from planned activity will be detected and the cycle is repeated.